doing the lab, okay? So I started recording. And okay, so today we are going to start C++. I would say, well, we are lucky this year because that's the first year we are really transitioning from C to C++ rather than transitioning from C to Java. So Charlotte, yes, I will post the slides directly after the lecture. Okay. So the transition is much easier, but also even if the transition is easier, I want to give a little bit of, I would say, smooth transition, or like to lay down some of the fundamentals and also some of the few differences between C and C++ that we might need, right? The problem here, if I go full screen in this wide monitor, you will not see very well. So maybe I just stay like this, and hopefully for tomorrow's lecture the internet be better and I switch to the tablet. But well, this is one of the very first examples we have seen in a C program. So it's basically doing exactly, it's doing nothing, right? So it just returns n to return 0. It's just like an empty main. We said before that any C program would have to have at least and at most one main function, right? Void can be written or can be removed, fine. If you move to C++, well, it's exactly the same syntax. Good. So you will again define your main function. You have to have one main. The simplest main takes no arguments and returns 0 for success. Good. Then, well, in C, well, we also had printf. The good thing about C++ is you can also inherit printf or most of the C functionality. Generally, as we'll see later on, you can run any C code in a C++ compiler if you use the correct header files. For example, here in printf in C, we needed to use studio.h, right? If you want C++ and you want to use printf exactly as you have done it in C, you want to include a different header file. It's called C Studio, right? Because it means you want to use some kind of C functionality. A general approach, and or maybe a general piece of information is that any function that is inherited from C and you want to implement C++, most likely you will find it in a header file starting by the letter C. So for example, here C Studio, later on we might be the C string, for example, right? But as you can see, this is exactly, aside from the C Studio, it's exactly the same syntax as C. And then, well, the new thing now is you can also print stuff on C++ using different way than like printf and scanf, like reading and writing. There is a cout and a cn, I'd say, function, if you can call it that way, and they are part of the standard library. So here, std and then Tocom, this is coming from object-oriented programming, as we'll see later on. But then basically cout allows you to print something out on the screen, and here you just print hello world, and again, new line is exactly the same syntax as the new line in the printf. So this program is completely equivalent to this one, right? Right, you print hello world here and there, but you print it here using cout, and here you print it using printf. Good. For this cout to be used, well, we said for printf you need C Studio. For cout you need a different header file. It's called iostream, right? You can think of iostream in C++ exactly as studio.h in C, right? It's the one that has the input and out from the, well, the IO stream, basically the screen, right? And then aside from this, a typical, well, it might not be very clear from this thing because it's intended for a full screen, a little bit larger. So after showing few examples, here is a general structure of a C program. So here you have the header files, again, coming from C exactly the same way. The main function, well, here it returns int and takes no arguments, the start of the main and the end of the main, and between the main, like the main body, you have the implementation of your main, basically, right? You have your variable definitions, you read something from the screen or you print something out. We have seen cout here, which is last, right? There is also cn, which is the counterpart of scanf in C. So this program, for example, you define a variable called double x, you initialize it to 0, and then you read it from the screen. So you ask the user to input, and the user inputs x, and then well, you check if the user, for example, inputted something that's more like a logical condition. If the user inputs something larger than 0, then you just print the square root of x. Square root is a mathematical function. This is why we need the CMath, right? And as you can see, well, we are in CMath because that's exactly the same header file from the C programming language. Good. Similar to C, every statement has to end in a semicolon, and well, other than this, the structure is almost exactly the same. I'll stop here and take questions. So Tianhong, will the model answer for the midterm be posted? Yes, I will post them. Yeah. Is there any question related to the lecture so far? I guess it's I would say with minimally changes, a direct application to what we have already learned in C, right? Can you explain STD again? Sana, we will come into it in a detail, right? For now, what you need to know is this CN or Cout, or in fact multiple other things, are part of the standard library of C, and you can include them by doing this inheritance thing. Later on, we can also really get rid of the STD by writing, well, a statement here saying using STD. We will see later on. But for now, take it as this is the where CN is being defined, right? We will explain it in detail later on. Okay, so going back small. So this is the example basically of the previous example, but I had it here such that we just look into it in online GDB. Okay. So here, maybe I'll just switch to the light mode. And then this should be also C++. Okay, then. Okay. So here, well, you can initialize it that way. You can also say double x equal just 0, 0, right? Both are okay. This is coming from the C, and this can be done in C++. Good. And here, while I ask the user to input x, I read x from the user. This is again similar to printf and then scanf. Then I check if x is larger than 0, and then I get the square root of x. I Cout it that way. Well, in fact, comparing Cout to printf is much more comprehensive and better readable, right? For example, here in Cout, to print stuff, you can print stuff in multiple streams, right? First of all, you want to print the string. So you say, well, I want to print a string saying square root something of x, and then you close the bracket equal, and then you give a value, and then you do an end line, right? We'll see how this works now, and then we replace it by printf. Then, well, let's just do this. Then if it's not larger than equal to 0, I cannot get the square root. So I say the wrong value, I cannot compute it. So if we run this one, I would say enter x, maybe 5. Square root of 5 is that, right? If I run and then I say, well, it's negative 6.2. Well, it's a wrong value because it's a negative number. I cannot get the negative for square root unless it's an imaginary number, right? So right now, let's see if I want to replace this one with printf, how it looks like. I would say printf. Then, well, I can easily format it by saying I start with a new line. I write the string exactly as this one, square root. But then now I want to have the placeholder of x. So I just have our specifier d as we have learned it before. Then I say equal, and then I want the actual square root, but this, well, x is not really a decimal, should be float, so LF or double, right? And then square root of x would also be another placeholder for a double, and then I am done. So I should just print new line. Good. And then here, the first placeholder is x. The second one is the std square root of x. And then by this, I'm done, right? So this is the printf. So to be honest, I favor printf over Cout because of how you can format stuff in a very rich format, right? You have specifiers or placeholders, and then you can fill them in, right? In cout, I have to do it one by one, right? So one stream, a variable, another string stream, another variable, and then std end L. End L is an end line, which is like equivalent to this thing. So I can replace this one with this new line thing. So both are equivalent as well, right? Good. Questions? We don't need curly brackets, Sana. That's a good question. So I said before, if you have a single statement for the if or the else afterwards, you don't need brackets, but it's a good convention, in fact, to have it no matter what, right? So that's, let's just add them. But here we didn't really need them because they are a single statement after the if and after the else, right? But just adding them in general is a good programming practice, even if you have a single state. Good. What is the part we use the square root? So here, right? That's this is where you square root, right? This is where you get the square root of the value x, calling the function square root, and it returns double, right? So you replace it by this one. Good. Okay, so switching back. This was the example we had. Okay. And then, well, after having this quick hands-on and like a very first my hello world C++ example, what is in fact C++, right? And why C++ compared to C? For example, why we cannot continue with C, right? The fundamental limitation in C that we needed C++ for is, well, object-oriented programming, right? C is not object-oriented, as we have said in the structure lecture. The best you can get is structures, right? So C++ compared to C is a multi-paradigm programming language. Well, it has the procedural behavior similar to C. It's also object-oriented. You can write functional programming in C++. It's generic through the templates and its own standard template library. And it has so many features, right? It's procedural again because underneath, in fact, C++ is mostly C in syntax, right? It's what makes the transition. If you learn C, well, it's very easy to learn C++. It's object-oriented. It has all the concepts of OOB, classes, encapsulation, inheritance, polymorphism, as we will see later on, okay? And then, well, it's generic because I can, well, there is this concept that is called meta-programming that it might be like a grad course in its own. But the general idea is in C++, you can make use of a feature called templates where you really define a function independent of the type, right? For example, in the exam, in the first question, you guys ask, should the arrays be int or double or anything, right? In C++, you can write a function independent of the input type, right? By using templates. And then it can work for any type in that sense, right? This is what it's called meta-programming. The program really gets defined when you really compile it, right? But it's something that we are not going to touch a lot in 2SH. It's an advanced topic. I don't even think in 2SI you will touch on it, right? And then it has the STL library. You can think of STL as the standard library in C, but standard library in C has a basic support for, well, basic math functions, etc. While the STL has support even for algorithms definitions, like if you want something like a data structure, like a linked list or a tree or a graph, they are all defined in STL, right? And we will make use of some of the STL functionalities and algorithms, as we will see later on, right? Then, well, comparing C++ to C in light of what we mentioned in the previous slide, a general rule is, well, any C code you can compile using a C++ compiler. So you can think of C as really a subset of C++ support. One of the differences that C++ has over C is references versus pointers. We have learned about pointers in C, and we use them to pass by reference, right? But C++, in addition to pointers, it has this concept of references that we will really touch on in detail what we mean by this. But just to let you know, for example, Java does not have the concept of pointers at all. It only has the concept of reference, right? C++, it has both. The pointers, exactly as in C, and references exactly as in Java, right? So it has both. Again, we will discuss the differences between both later on. And then, well, C++ generally a strongly typed language. Well, the word strongly typed is usually used in software engineering to identify a language that really you have to be very specific, very strict about how you define things. For example, some of the automatic casting we mentioned that is happening in C, well, it does not happen by default in C++. To understand what is really strongly typed versus not, compare Python to C, right? You can easily say C is much more strongly typed than Python, right? In Python, I can define a variable as int, later on use it as a string completely fine. Python has no problem. It's a very friendly language, right? But in C, well, if you define a certain type, you have to use it in this type, otherwise you get an error, right? So C, in that sense, is strongly typed compared to Python. C++ is even strongly typed than C, because, for example, some of the automatic casting does not happen in C++. You have to do it in your own, right? Well, and then C++ supports this notion of immutable variables, and well, we'll touch on it later on. We didn't talk a lot about it in C, maybe a little bit more about the constant stuff or static stuff, but leave it for now. We would have a lecture about that, right? And then C++, by supporting object-oriented programming and templates, it abstracts really the type concepts. I give you the example of you can write a function using templates that can work for any input type. In that sense, it has a rich abstraction compared to C. Good. Questions? Okay, so I don't see questions so far. So I hope, well, this is all theoretical, but it's good to know, because once we start having some more hands-on, we will refer to some of these differences here, right? Here I show you one example of references versus pointers, right? To give you a hint of really what is the difference. So in C, to be able to pass something by difference, you have to do what is here in the left, right? For example, if I want to write a very simple function called the increment, previously we have wrote the swap function as well. So increment takes a single int variable and it increments it. But I want the value to be reflecting back in the main or in the caller function. To do it, we have to do it passing by reference. And to do it that way, I have to define the input to be a pointer to the variable, not the variable itself, right? By defining it that way, when I call the increment, I send the address of A, like the AND operator of A, and in that case, A will get updated here, right, in the main. This is usually the pointer way of doing passing by reference, right? In C++, well, this is all supported in C++. You can do it the same way, right? But you can also do what is called pass by reference. You don't need to introduce pointers at all if you want. You can just simply, when defining the function, define a reference to the input variable by using the AND thing instead of just passing the A itself. And by doing this, if you only pass A here, well, it will be passed by reference by default, right? So here you say that the function increment for C++ takes a reference as an input to the A variable, right? So it takes the address, but as a reference, not as a pointer variable, right? Here, the function increment takes a pointer to the variable A, right? And here, to be able to access A, you have really to access it through the dereferencing operator, which is the asterisk. Here, I just update A directly, right? Good. And these two really are supported in C++, while the left is only supported in like basically the C only supports the left one. It does not support the right one. Good. Okay, so I see that the lecture is already over. Maybe I will just stop here. Everything else is really also straightforward, but maybe we can spend tomorrow first 10 minutes to continue this. Again, I will upload these slides along with tomorrow's lecture slides to Avenue today. Good. Thanks everyone, and yeah, see you tomorrow.